Hey YouTube, welcome back to the garage. I took a little bit of a break there from the scraping. You guys might recognize this part. I had a little change of plans. I actually had to watch the last video to see where we left off on this. We were doing some measurements on the saddle here, but to be quite frank, the shop and the workbench and everything just got way too sloppy, way too dirty. It started lending to some frustration in sort of the final measurements. So what I decided to do was hold off on the actual scraping, clean this place out, really scrub everything down, and I'll give you a sneak peek of where the grinder is so far. And I've gotten to the point where I'm ready to pick this back up again and start to scrape in these last 4 surfaces here and 1 on the table. In order to do that, I'm going to have to whip up a little scraper to be able to get into these small dovetails. I don't think I'm going to be able to pull scrape in here. I have no idea what a pull scraper looks like to get in underneath these small dovetails. I'm going to go, to this, make essentially a smaller version of this this Anderson style push scraper. This is just way too big to get in there and get all the way to the bottom. And that's the point of this video. I'm going to warm up a little bit and just walk you through making a small version of this scraper. I don't know how exciting this is going to be, but we'll braze some carbide, make a handle, make a little scraper, sharpen it, and just get ready to start pulling these surfaces in. And here's how the grinder's coming along. Like I said, I really had to clean this place up. It was just getting way too filthy, grit and grime everywhere. Every time I'd test the saddle up against the machine, I was just transferring dirt back and forth, and it was just a mess. So as I started cleaning stuff up, I decided I would just degrease some of the parts. One thing led to another. I apologize for that orange. It didn't look quite that bright when I was picking that color out. So I've got a small carbide blank. It's 1/4 inch by a 1/16, I think. The original plan was to cut off, lengths of this and put them on a shaft, this way to exaggerate. I was thinking about a 1/2 inch long, and I'd have plenty of pieces to explore. Now that I have this, I'm thinking about going the other way, in line with the shaft, and getting a little bit more length to give me access into the small dovetail. Now the trade-off there is that I only have a 1/4 inch wide bit. That seems a little bit small. I would have much preferred, like I said, about a 1/2 inch. But we'll give that a try. Other than the losing some of that width, I might give myself maybe 3/4 of an inch to an inch protrusion. I'm a little bit worried about how brittle that might be, the carbide, if that breaks easy. I mean, I'm sure it'll hold up fine to the scraping, but if this thing rolls off my bench and that takes a hit, it's a goner. But we'll give it a try and we'll see how it works. I've got the carbide. This is just maybe a 3/8 stainless steel. And we'll silver braze it onto the end. I've got some black flux here. And then we'll make a handle. Now I've got file handles, but nothing quite this big. I think I'd like to make something more of a round pommel, just so I can, I've got some good purchase on it and I can really put some weight behind it. We'll make a similar ferrule here. And for size, I just went through my screwdriver collection and played around with these, near the saddle. And something like this seems like about the right length and size. It's about 8 inches, I suppose, plus, some of the scraper tip. What I plan to do is mill a slot in here to receive a piece of this carbide. I'm just going to nick this with a little diamond wheel and just snap it off. So I've got the round in the vise and just a 1/16 slitting saw. I measured the carbide. It's actually a hair oversized. So we'll see how well that cut is. Otherwise I'll just clean it up with maybe a small file if it's not too much work. I wonder if that'll focus. So just a little slot. broke off a piece of the carbide. Let's clean it up a little bit. Just a rough diamond plate here. I just want to make sure we get a good bond with the brazing. That's where I nicked it with the diamond cutoff wheel. And then I gave it a sharp tap with a hammer. You can see it broke exactly where I wanted it to. Stuff's been sitting a while. Looks like it separated a bit. Don't quote me on this, but I don't think this the black flux burns. So as long as there's some on there, some fluxes tend to just burn up and cause problems. Hopefully this doesn't move when I get the silver in there. Just wire brushed it a bit. Some hot water gets that flux off. Got a little bit too much flow on the bottom. I'm going to knock that off with a file and just spin this in the lathe with some sandpaper just to make it look nice. Alright, going to call that good. I'll just make a handle on the ferrule for this end. Next up, I'm going to make this ferrule. I'm going to be turning some wood for the handle, so I'd prefer to do that last just so I can clean the lathe up quickly. Now this has a small return on the top. Looks like it's got a little bit of flare at the bottom. It just looks nice, the little flare. The return at the top I think will be useful. Now in order to do that, I'm going to be using the metal lathe in maybe a bit of an unconventional way. I have some 1-inch thin wall tubing. I think it's about 40 thou. And what we're going to do is use this very, just a round polished, I think like a 1/2 inch CRS, and just push this metal over. I'd like to get it as close to center as possible. Maybe just drill it for 3/8 for the scraper tool to come through. So I've got the tool mounted on the lathe at about 45 degrees. That's just so I can work on both sides, as I roll this tubing over. I'm going to set this to its maximum speed, which in this case is about 1200 RPMs, I believe. I'm going to take it slow and move the metal gently. Again, not very orthodox. Just be careful if you try this yourself. Jaws aren't hot, tool holder's not hot. I think I went a little too aggressive on that. I'll show you a close-up, but there's a little bit of a fold in the metal. I should have, if I would have been a little bit more patient, it would have gotten hotter and maybe have flowed a little bit more uniform, but I don't think that's going to make any difference at all. I'm just going to clean up this hole so we can get the tool through it. Okay, I think we should be able to see it better here than on the lathe. I just cut it off. Did a small chamfer on the inside just with a deburr tool. Some sandpaper, wire brush, and hit it on the buffing wheel. Here's the defect that happened from just going too fast. You know, when the camera's rolling and the pressure's on. It's fine for what we're doing here, but that could have been a nice continuous surface. I should have waited a little bit more and let it get, you know, up to temperature before I really started pushing with the dials. 40 thou metal isn't that hard to move, so it wasn't too, you know, a heck of a lot of pressure on the machine screws. That'll just go on like that. Only thing left is the handle. I don't have a piece of wood large enough to make a nice size handle. I just went out and grabbed this off the log pile before you guys start laughing at me. I'm going to cut out a piece here, just kind of round it out by hand before I put it on the lathe. I'm not going to show that on camera. I'm going to do this in the press. Right there it is. Just sharpen that end, going to force it down in there. I think I'm going to cut a flat on one side of this to keep this from rolling. Yeah, I'm going to have to take my time sharpening that. It's not too bad, but could cut a little bit more.